Hello, this is video number 3. We're gonna finish up example 2 of page 502 of lesson 8.1. We were saying that we can use the polygon interior angles theorem for many things. In this case, they tell us that the measures of the sum of the interior angles of a polygon is 900, but they want to know how many sides does that polygon have. So since we don't know the sides, we substitute with the n with nothing. It's the n minus 2 times 180 must equal the 900 degrees. That is the sum of all the angles. Instead of distributing the 180 over the n minus 2, we divide both sides by 180 degrees, and in here we get that 900 divided by 180 is 5. 180 and 180 simplify to 1, so we end up with n minus 2 equals 5. Add 2, n is 7. So we just discovered that the polygon whose sum of its interior angles is 900 degrees is a 7-sided figure, 7-sided polygon, or a heptagon. So now we go over here again. Remember when I drew all the diagonals of this octagon, 8-sided figure, 8-sided polygon, we ended up forming 6 triangles. And also remember that we have studied, like in 6th grade, that the sum of the interior angles of any triangle, they add up to 180 degrees. Well, if I considered these 6 triangles that came out of drawing the diagonals in my octagon, if I added up 180, 180, 180 6 times, I would end up having the sum of all the angles. This one and this one, this one, these two, I would end up with, if I added all of that, it would mean adding 180 1, 2, 3, 4, 5, 6 times. Well, the figure has 8 sides and 6 triangles. That's why that answers why we have this formula. 8 sides minus 2 gives me the 6 triangles in this figure. 6 times 180 will produce the sum of all the angles in the figure. Take a look at this quadrilateral. 4 sides, it has 4 sides. How many triangles are there going to be formed? Well, it's the number of sides minus 2 tells me the number of triangles that are formed if I take a given vertex. In this case, I'll take A, and I'll try to draw as many diagonals from A as I can. It just happens that there's only one diagonal that I can draw from A, and that divides my quadrilateral in 2 triangles. 2 times 180, 360. That's corollary 10 derived from theorem 8.1 that says it says that the interior angles of a quadrilateral is the sum of the interior angles of a quadrilateral is 360. 360. So now we go to example 3. Example 3 says, find the value of x in the diagram shown. Here's a diagram. We have a quadrilateral. We know that the sum of those 4 angles should add up to 360. X plus 108 plus 121 plus 59 should add up to 360. Add these numbers, we get 288, subtract 288 from both sides, and we get that the value of x is 72. And we just found the value of the measure of this angle, 72 degrees. So your homework will be page 504, exercises 3 to 9, do the odds. I could post